Hello good people, I'm going to talk about classification of matter. More specifically, I will be talking about the states of matter. To that end, let me bring in some round bottom flasks. And here they are. So on the far left, we have some sort of purple substance, possibly crushed hopes and dreams, in its solid state. So that's what I'm going to write. If I increase the temperature, eventually I will reach the melting point of this substance, and it will turn into a liquid, which we have here in the middle flask. The temperature of the liquefied hopes and dreams can be increased further until we reach the boiling point, and the liquid turns into a gas here on the right. So in short, matter can exist in three states: solid, liquid, and gas. The state a particular matter is in will depend on temperature. If we start with a solid and increase the temperature until we reach the melting point, we'll end up with a liquid, and if we increase the temperature even further and reach the boiling point of the matter, we will end up with a gas. Conversely, we could also cool the gas down to a liquid and then cool the liquid even further until we reach a solid state. So these changes in the physical states of matter, going from solid to liquid to gas, occur at a microscopic scale. A microscopic scale simply indicates that something is happening at a level that is observable by the naked eye. However, in chemistry, we are very much interested in what is happening at a microscopic scale, or more precisely, what is happening at the atomic scale. To that end, I'm going to bring in three more round bottom flasks, which will represent what is going on at the atomic level. And here they are. So once again, on the far left, we have solid, in the middle we have a liquid, and on the far right, we have a gas. Remember that we can represent individual atoms as spherical particles. And so in this case, each one of these little spheres represents a single atom or particle of crushed hopes and dreams. So what is the difference in what is happening to these atoms when they are in a solid state, liquid state, and gaseous state? In order to illustrate what is happening on the atomic scale, I'm going to bring in another atom outside of the round bottom flasks. And here it is. To start with, I'm going to place this atom in the flask with the solid. In solid state, the atoms are packed close together. And the way I have drawn it, it seems as though they are not moving. However, they are vibrating a little in place. Maybe like so, there is just a little bit of movement. However, mostly they're really packed tightly together. All right, what happens if I increase the temperature? Well, as I increase the temperature, I will provide individual atoms with more energy to move. And so slowly they will move further apart until we end up with a liquid state. So now in the liquid state, the atom can move a little bit more freely. However, it still stays in contact with the other atoms. So it can move around and through and up above and then down again. All right, so what happens once I provide more energy? As I increase the temperature, each atom is getting more energy that it can use to move. And now the atoms can bounce further apart. So much so that eventually they are moving completely independently from each other. And that is what we have in gaseous state. All of the atoms are moving around and interacting very little with each other. So in summary, as the temperature increases and as matter changes states from solid to liquid to gas, the individual atoms have more and more energy that they can use to move. In a solid state, individual atoms do not have as much energy and so they stick close together. In a liquid state, they have enough energy to move a little bit about, but they still remain in contact with each other. In a gaseous state, each atom has enough energy to bounce around freely without necessarily interacting with the other atoms. Conversely, as matter cools down, the atoms lose energy and they start to settle down, firstly back into liquid state, where they're interacting a little bit with each other, and then to solid state, where they're completely locked in place. That is all for now, and I will see you on the flip side.